Excellent. There we go. All righty, let's get started. So, hey, everybody, welcome. I'm Steve Lander, Director of Pavement Management for Withers Ravenel, and today's Lunch and Learn is on creating accurate roadway inventories through AI. So, we're going to be exploring AI-powered solutions to enhance your data collection. So, I hope everybody's well. Um, I just got over COVID, and COVID is really hitting, but at least it's not hitting like it did. But it's something a lot of people are getting it these days. Anyway, I hope everybody's well. And our intent with the Lunch and Learn is to offer new practices and products. So this is a product to help collect data in the field in conjunction with a pavement condition survey, or maybe not. Maybe it's a standalone. We've looked at the data with a couple of demos, and we're really satisfied with it. So I think you will be too. And when Jason gives a presentation here, couple items, housekeeping. If you need PDHs, Deanne's going to be putting off in the chat area. She'll put the link for PDHs, and there'll be a couple other links too. One for our website, Withers Ravenel, one for Transconomy, and we'll also be posting Jason's email address and also my email address. And so as we go along here, you can ask questions. If we don't get to you, we will get to you at the end. So like I said, if you get one PDH, all you need to do is click on the link, fill out the form, and you get a PDH. For attending here, all of these lunch and learns are recorded. So if you missed one last month or the month before, we have them. And if you have to leave for any reason, we can certainly get you the link and you can still get your PDH credit. And we can also get you a copy of the presentation. I always run this by everybody. We try to offer up best practices in our profession, and so if there's something that you want to hear about, just let us know. Put it in the chat, maybe send me an email, and we'll see if we can get someone to talk about it. Maybe one of our folks, and maybe somebody from the outside. Alrighty, so the format of the Lunch and Learn is that Jason's going to be presenting for roughly about 30 to 40 minutes. He also has he's got a website he can pull up and show us some live data. Everybody's on mute. We would like to create an environment where you can ask the questions, and when you ask them, I might interrupt Jason to answer the question. Hopefully, we can create a conversation more than just being a formal presentation where you just kind of sit through it. So throw the questions our way and we'll get them answered. So the formal introduction is that Jason and I, Jason Trotter, we've known each other for, Jason, I don't know how many years it's been, but a good long time. He is the Director of Business Development for about 9 months with Transconomy, and I knew him when he was with his former company. And when he switched over to Transconomy, I knew that this must be a company of value because that Jason, he's a no nonsense guy. He tells you like it is, and so I was curious, and then we engaged, and so from his 20 years of experience, local and state agencies for pavement management, asset management. Experience includes pavement condition assessments, ground penetrating radar, falling weight deflectometer, right-of-way assets, and management systems for data analysis, working with civil engineers. I can't believe that, but software professionals, data technicians, and data scientists. So worked for over 20 DOTs, numerous cities and county agencies, and he is also was a goalie for quite a number of years in ice hockey. So with that, I'm going to turn it over to Jason.
Thanks very much for the kind introduction, Steve. It's very nice of you. Although anybody who knows hockey may suddenly tune out knowing I'm a goalie. They have a reputation for being a little odd and crazy. But good morning. I want to thank everyone for the opportunity to speak with them today, and to Steve and the Withers Ravenel team to discuss, how AI can assist you in creating accurate roadway inventories. Obviously, the need for data and the use for data continues to grow, and more programs and policies are relying on accurate information. And we want to bring an approach that is, I think, both affordable and fairly easy to implement, which creates an availability to do or collect this sort of information in a manageable way and keep information up to date, which is obviously a core part of transportation asset management. So today we wanted to discuss, well, how do you solve the problem? There are so many different assets out there. I think there's pretty robust programs around things like pavements and bridges and always have been, but now we're seeing a greater need for current information on signs, on sidewalks, on drainage information, all sorts of areas. And that's really a problem that needs to be solved because it hasn't been a strong focus. Solving a problem involves finding a solution that is affordable and implementable and allows people to gather that information in a meaningful way and use it in a meaningful way. And we're going to talk about how we've done that at Transconomy today. But in addition to, hey, here's how you're able to do this, you also need to be able to discuss, well, what are the limits of this? What problems can it solve? What problems can it solve? What are the benefits? What are the limitations of that technology? And lastly, I think there's nothing better than bringing in real world experience or real world case studies around, well, how has this been implemented? It's great to talk about technology, but where has it been used? What have people done? How have they found that information? So that's the approach to today's discussion. As Steve mentioned, absolutely love to have an interactive discussion, answer questions. Feel free to speak up at any point, so to speak. Send the note in the chat. More than happy to address questions as we go or at the end, whatever makes sense for most people. So for today, what we really want to do is identify a new technology to reduce costs in your asset management data collection practice, introduce something that you can understand the benefits and limitations of using AI in your asset management data collection program, and also understand how using this technology can reduce risk to your agency. Simply, we want to miss the capability of AI and artificial intelligence. You hear that word absolutely everywhere for all sorts of things, not just in engineering or not just in transportation, but all over the place. And so trying to understand, well, what is it exactly? And in this case, what is it around transportation asset and how can it be used is an important part. And we want to try and make that approachable and understandable for everyone. So really, we identify the problem of being, do agencies know the presence or condition of their assets? And in our experience, there's a lot of cases where people simply don't. They may know pieces or they may have very old information, but knowing all of the different assets that are out there is challenging. In many cases, they are not current and accurately collected. So we've come up with a solution that is both scalable, affordable, and it enables a quick identification and condition assignment to roadway assets within a transportation agency's inventory. Ideally, this results in improved condition, safety, and mobility for our nation's roadway infrastructure, and it reduces the risk. Having a way to do this quickly and easily is probably the most critical element to bring in place. And many times it's just, can we time it with whatever other program we have going on, or tying it into other major surveys, or so finding this way that allows it to be done as needed in innovative ways has been important. And we think this really provides a good opportunity for people to take advantage of what today's technologies can offer. What gets measured gets managed. Pavements have been measured for a long time. Bridges have been measured for a long time for various needs. Other assets haven't had as many demands that way, so it's been less structured, and we think there's a great opportunity to bring the state of practice forward and give people a better opportunity to do it. One of the critical aspects is, how does it work? So what is this AI approach, and what does that mean, and what happens with that sort of information? So images need to be provided. So images can be collected using a collector or navigator app, or we use standard tools like a GoPro camera, an Insta360 action camera. You can use smartphones. We can also ingest geocoded images from previous surveys or other things that have been done. And you can also bring in things like drones or aerial imagery to use for your asset extraction. That information gets uploaded to the AI system that you're using, in our case, Transconomy Hub. And there, the data gets anonymized, it gets validated. And then what you're going to do is run through the various algorithms that are applied based on the type of data you're looking for. Are you looking for a sign inventory? Are you looking for some sort of pavement condition assessment? Are you looking for other roadside features, possibly sidewalks, possibly your pavement markings and pavement striping? All of that is going to be run through the advanced algorithms to produce this data set for you. So I'm going to go through a stratified quality control process. While AI is very good, you do need someone to take a look at this data and make sure whether it's a wonky technology component where suddenly an asset's appearing in an odd spot when it should be over the roadway due to some sort of GPS interference or whatever may be going on. You do want to introduce a quality control component, and then the data can come out in many, many formats, but basically it's simple formats that can be used standalone, such as things like a spreadsheet, an XLS or a CSV file, or it can come into things like shape files and KMLs and all sorts of various areas, depending on whether you have existing management systems you want the data to come into, or whether you're just looking to have it as a standalone element that you work from there. And the goal is that data can now help in decision support. In order to do this, one of the most critical things is building models. Now, one of the things that's been very interesting for me, having just moved into this AI area, is understanding all of the work that goes into actually building a model. So when you're looking at a model, it's focused very much on an asset. So if we look at that step one preparation, you need to prepare a clean data set with annotated images for each asset. And we're talking about 40 to 50,000 images for each asset. So if that's the sign inventory as an example, we need to train what is a sign. So you have these bounding boxes that show sign within the image, and you have notations around what type of sign it is or any of the information that's going to be used to train the model. So once you have all these annotated images, they move into the model that you're going to train. So there's many open source models that are available, but from there you need to enhance and make them your own through this training model. And typically it is an iterative process. You're going to run through, you're going to see your results, and you're probably going to have to spend a little additional time going through what it takes to get it up to speed. When you're at a level of comfort, you're able to deploy that model. So if you want to look at a sign inventory, I want to get my guardrail, I want to look at my pavement striping and my pavement markings, you can deploy that model and use it to run through and do the asset assessment from the geocoded images. For us, Transconomy, until we're at a 90% confidence level in all the data, then we're not going to use that. Once we hit that 90% confidence level, we'll start to deploy a model and continue to do the feedback and retraining, which is another critical component. You need to monitor the performance of a model and retrain the model to increase performance. There can be edge cases, so very particular elements around how an asset is looked at, coding, for example, like MUTCD around the sign codes or various things like that. So you're always looking to try and enhance the model as you work through them. Process like this is at 40 to 50,000 images per asset. So it's not a light process. It's a good process to go through, but it is a bit of work to build these models up. And again, when you're looking at using AI, you're identifying how are you going to identify specific aspects of a single asset, as opposed to, say, a manual method where you can look at 4 different assets at any one given time. This is very specific on a per asset basis. And one of the benefits from that for AI is the accuracy associated with that asset that comes out of that training and development. And really the advantage is AI can detect and rate condition of any asset within about 20 feet of the roadway. If we look at this particular image, there's somewhere around 17 or 18 different assets that you can look at. So we've got pavement conditions, we've got all sorts of right-of-way assets like the poles and the signals and the signs that are hanging off it. We've got signs in advance down by where the van is. So when you look at a right-of-way image, there's a significant amount of transportation infrastructure information that is within any particular image. And this is a great way to be able to extract information that people are going to use. One of the things that's been critical for us and an element that we strongly believe in is the data should meet recognized reporting standards. So all of our models are based on some sort of aspect that people are using within an agency. So MUTCD or PASER or Meyer aspects around the various assets we look at. We think that when you're standing behind the data and you're trying to have this defensible data, you want to have a way it can be developed, and where did this come from? How do we determine what these criteria were on what we are rating condition inventory for? Now, it doesn't mean you can't turn it into, for example, PASER's a 1 to 10 survey. It doesn't mean you can't also produce, a good, fair, poor summary and a nice heat map out of that. But how you're evaluating is being developed from something that's a recognizable standard. I think that enhances the defensibility and ultimately the reproducibility of the data in the long term. What are the benefits of taking this sort of an approach to collecting asset information? One of the key things is really collecting asset information quickly and relatively cheaply. Data collection is typically done with everyday tools. There's a lot of great prescriptive tools out there that do a very good job. It's where I spent most of my time in the industry. But the demands around the data are continuing to grow, and the need to be able to get out and grab information is important. And it's important to be able to have that geospatial and have that readily available and done quickly. And sometimes it's not on a whole network. So being able to take things like GoPro cameras on a pickup truck, or using overhead imagery or using drone imagery are all elements that allow people to then be more nimble in how they are approaching data collection for asset management. We find that just gives an ability to operate more quickly and without necessarily all the operational planning that has to happen when you're looking at other aspects towards projects where you are bringing in a prescriptive vehicle or some of the elements that come with it. You can also have access to quality data with which to make data-driven decisions and performance-based decision-making. So as I mentioned, we want to give you ways to visualize or build dashboards or slice and dice the data any way you want. So you've got that valuable image that people like to have for the context of what is it we're looking at. You've got it from a map-based solution to see where in the world is this happening. You can take in these standard files like the CSV or the KML or any sort of GIS file, or you can bring that out towards something like a dashboard where you can have summary data and work through all the various elements you want and slice and dice that any way you need. I've always been a big believer in the value of imagery around asset information or pavement condition, that context that people are looking at. And these are great ways to be able to bring that to play very easily. You can take this data to the field. Certainly one of the things is what's happening in the office relevant to what's actually out there when I go on site. ArcGIS field tools, as an example, allow you to take that data in the field. Your inventory, your conditions are connected between the field and the office. You can go have a discussion in the field and look at what's been reported in your systems. So you're not sort of debating one aspect and the other completely disconnected. I think that can improve communication, obviously can help with the decision-making process when we're able to see these things real time when you're standing out there looking over whatever piece of data you happen to want to be looking at. What else can we do with this? I mean, I think it's a goal of everybody to try and drive the politics out of decisions. Typically, GIS reference data, things that can be plotted and mapped and shown visually help with that, right? We're dealing with standards based, we're dealing with information that we can look at and pull up and do comparison contrast to. So the idea is really we can drive the politics of decisions. I don't think anybody expects it'll ever be gone, but we're trying to put this data component to the decision-making process and have it bring more forward and be more a key influencer in what actually happens in that decision-making. You can look at updating information in real time, and we're talking about with certain technologies. So for example, lots of agencies are using dash cams and other types of technologies to manage fleet systems, to do safety enhancement for fleets or other aspects on what they want to do. A lot of those cameras can be used for elements of asset extraction using AI. The question is what technology makes or what assets require that sort of frequency and update. But it's an option for you depending on what you're looking at doing. You're able to start taking that information into account as opposed to these 3, 4, or 5 year gaps for updates. You can look at bringing things in different where you need it. We can create a digital twin of asset inventory and conditions. Probably one of the most powerful things these days is actually having a full inventory of all of our information, where we need it, referenceable for people, things that can be plotted, considered, and planned around. That's a really critical element to any asset management program. And that in and of itself will help improve resiliency. I think everybody's hearing more and more about, more challenging weather events and the frequency of particular weather events and things like that. Many years ago, I was involved in some work where there had been a weather event, and we had to go back through and try and look at, what were the impacts from flooding in some of these scenarios. So having information available, with a date and time when it was collected and something like this. So for example, if an event happens, you go out and see that impact by using just these off the shelf, readily available, often already in use tools to grab that information. And now you're able to improve your resiliency because you can see what's happened and impacted from it. The ability to even build that initial twin of asset inventory and conditions is a great starting foundation for having that capability moving forward as you need. The reality is there is limitations to what can be done. In this case, we're talking about a very specific, non-hardware specific, no software required. So it's a very flexible way that you can go out and grab this information. But what happens when you do that? What are the limitations from that? So, one of those things is you absolutely need to look at having some sort of quality control process. Even the best AI models have a degree of uncertainty. There's always a need to go through and ensure that things are running well that way. So if someone says, hey, we never touch the data, I'd be nervous about that. It's something that you really need to take a look at and build in a quality control. And it really does two things. One, obviously, whatever project you're working on, it does the validation insurance of the data for a particular program or project that's being run. Secondly, that's the key component to how you start to improve models. Models continue to improve based on the fact you're finding an error. And one of the benefits with AI is you have an error. It's a systemic error. It's happening because the model is not recognizing something. So by finding that error, by retraining the model, you've now taken care of that error across the board because it is systemic. And once you fix it, that error is not going to happen anymore. Stratified quality control is key to helping that continue to develop within the models themselves, in addition to that important criteria of delivering high quality data for the customer, the project you're working on. Because we're based on visual assessment from imagery, there is limitations based on, trucks, cars, vegetation, obstructions, the Coke truck or the Pepsi truck's doing a delivery as you drive down a block. Things like that are going to happen. Obviously, if you're in an urban area and there's better times to be collecting imagery where it's less likely to be impactful, you can do some operational planning around that. You try and do everything you can to take that into account. But the reality is there's probably always going to be at least some images where something is impairing the ability to see and provide that model. So, you have to be aware that can happen, and 90 to 95% is considered very good in terms of the recognition of all the imagery that's out there and being able to pull the full asset extraction out of it. Oversampling can also be a bit of a limit. So one of the first model that we developed was automated sign inventory. Obviously, signs is a prevalent asset for every organization at all sizes and and agencies. So sign inventory is the first one that we worked at. One of the things that happened with signs, which we have an incredibly great model around the signs, is you get these edge cases of signs that are kind of on the boulevard right close to the right of way. So where is the ownership of it? So you need to look at ways to enhance that, again, with the quality control process that runs into it. Also refining things like your area that you're pulling the images from, so that you don't have what is a sign, but that sign is not within the ownership of the agency that the work is being done for. Just something to be aware of. Ultimately, this can really lead to a reduction in risk to the agency. as we said, there's a lot of different programs and policies that are looking for information to try and make decisions. So whether it's a roadway safety audit, whether it's connectivity, obviously connected and automated vehicle with lane striping is becoming something that people are looking more and more at. ADA compliance, you know, there's a whole list of items here that obviously can feed it. And so what's critical is these AI-based extractions can feed information into that. And because it is simple to do, we can take a look at things like corridor studies or just certain aspects within a program, as opposed to the complexity sometimes of pulling together a full prescriptive data collection program that has more elements around the operational planning. You know, using these everyday tools and still getting high quality, very good data gives you an ability to bring that information forward and make informed decisions around asset management, around, well, where are my challenges for mobility studies, where do I need to look at crosswalks because I'm trying to improve safety, and are these located appropriately? Do I even know where I do or don't have an ADA ramp on the corner to start with as a basic inventory and feature that's happening out there? So there's a lot of ways the data can be used, both at the network level and at smaller levels for, you know, whether it's condition assessment and inventory, whether it's integrating data into a database or supporting the decision-making process. I just want to talk about a few programs that we've done or projects we've done and some of the assets that have been done with them to give people a sense of what we're looking at as it relates to these. So the city of Bowie, Maryland, we did a roadway asset and pavement evaluation. So it's a 100+ lane mile system. Within that, there was, you know, a little over 7,100 signs, 22,000 point assets, of which we did about 9 different types of point assets, I believe it was. There was 433 linear features. So again, looking at things like sidewalk or guide rail or any sort of line-based asset, as well as a pavement condition amongst the entire network. So some key things about that one, it was delivered in 4 weeks. So for the client, the ability to turn that around in a much shorter time frame as opposed to a more extensive or months down the road was really important to them. It gave them the information, plenty of time to start into their budget process, and then it gave them all these ancillary information related to their other assets that they were able to start thinking about. And then come back and said, you know, we can actually now afford to do this on an annual basis as opposed to doing it every few years. We've already done a second survey for them. So the quality of the data, in addition to the affordability of the data, has been a real enhancement for the city of Bowie itself. The Richland County Regional Planning Commission is an MPO based in Ohio. So they were doing a pavement condition assessment and an asset survey related to developing some safety enhancements for their program. So it was 19 different townships, a number of different municipalities within the townships and underneath. So it was a pretty comprehensive survey, and some things were done network wide, and in some cases we were looking at assets particular to one or a few of the agencies within the actual our CRPC itself. So you can see there's traffic signs, lane markings, sidewalks, manholes, pavement conditions. So fairly comprehensive on the various aspects that were being looked at. They're using their pavement survey to make their maintenance, preservation, and rehab decisions. So sort of a core focus of what typical programs like this will do. So a PASER-based rating system on a 1 to 10 scale, but again, that ability to bring things down into the good, fair, poor. So within that, they're able to, you know, click anywhere on the map and look at a segment and see what it is, or just click on the actual pie chart and then see, I just want to see where my poor conditions are, and they're just going to see those roads pop up. But it's giving them the data to start to determine, well, how do I want to go forward in looking at improving my my overall condition index? How do I want to look at what do I need to have for a budget long term? They're doing a sign survey. Our sign survey was delivered so that they're able to do a holistic sign replacement strategy, so they can look at what sort of signs do I have in addition to the 41,000 signs that were collected. It's got which ones are regulatory, which ones are guide and informational signs, you know, all the different codes and signs that they have out there. And again, an assessment based on good, fair, poor, as well as ones that could not be assessed well. You're able to take that information and again start to put that into a program. You see at the top here, you could actually also drill down into things like, well, I want to look at a particular region within the overall network, or I just want to see my arterial roads versus my local roads, or what have you within that information. Again, you're now able to start to filter down into making some decisions based on here's the actual information that I have out there. So when they're looking at a sign, for example, we got one that's in a fair condition. So we've got an individual asset ID unique to that sign. We get an assembly ID, so that's going to be the post or the pole or whatever it's mounted to. If there's 6 posts on that sign, they're going to know there's 6 posts on it. If there's one on it, they're going to know there's one on it. So you can see, the type it is. So the MUTCD guide sign, what is the code, what is the name, all that sort of information that goes in there, allowing them to take a look at this and decide what sort of aspects they want. Things like post condition. Well, it's leaning. The post in itself is leaning. It's ground mounted steel post. And then we provide some standardized comments around conditions. So the sign post is slightly leaning and the sign has minimal discoloration. So not anything that's overly critical. If you can't read what the sign is, obviously that can be more of a call to action. It's going to be under the poor condition as opposed to the fair condition. But what you're able to do is then start looking at where are my most critical areas, where's my biggest risk, what's really in rough shape that I need to start to get a handle on, and how many do I even have? Like, what is the value of my full replacement? Have I even thought about that, or do I have a number to understand what our risk is overall? We also use aerial imagery to do a full inventory of sidewalks as well as a measurement of the width of the sidewalk. So in addition to the length, here you will also see the width of the sidewalk. They're doing this to determine where sidewalks are undersized. They had some concerns around, if I've got the right width or not that needs to be done in there. So you can see it's a little tough to see in here, but you can see where the sidewalk would be marked out there. So gain the unique ID and information on location, like, what street, what area was it done, et cetera, also the length of it. But this information, again, they're now going to be able to pull stuff out that says either it's in poor condition. They can start to look at which ones are meeting the lengths or the widths, they need in place. Again, you slice and dice all this information up to help you make informed decisions and prioritize where that time and limited budget dollars are able to be used. Another project we worked on, and it's a neat one, was to assist VDOT with the digital data collection effort for park and ride lot asset condition over a very expedited timeline. One of those projects where, if there's funding available or there's leftover budget or something, but hey, we only have this amount of time to go in. So it allowed VDOT to plan both the near-term and future maintenance efforts on an asset they hadn't put a lot of time into. These lots are spread all over the state. They're not easy to assess. They're not on the main line that are being collected necessarily through the traditional program they have. So we were looking at 127 different lots that were owned across the state. So I want to look at pavement condition, drainage, some ADA questions, and some pedestrian facilities, as well as lighting, safety, and security. So a fair bit of stuff was being done. And one of the aspects of our play was the use of small unmanned aerial systems or drones. It's a great opportunity to do that. And this one actually really expedited. So it was on time in 6 weeks to give the data to VDOT because there was this crunch around the funding availability. But we were doing 20 different lots a week at that point. So the data be collected by our engineering partner on this project. They upload the data to our system, and we're able to turn around the components that we were looking at there. So it was a two-pronged approach to how the data was being assessed in this case. So from the aerial imagery, from the drone imagery that was collected, those were used to do a Paiser rating on the lot. So either a single overall assessment for some of the smaller lots or area-based assessments for larger, a range of facility sizes that were involved here. In addition, there was what are the inventory of the lot in terms of what are the parking stalls available, how many parking stalls could be available in that lot, and which of them were occupied at the time of the survey. I'll be honest, I can't tell you exactly why VDOT needed that, but it was a critical component. They just wanted to see in terms of what's available and what was the occupancy. In addition, there were on-site inspections done by the engineering partner to look at some other detailed information, some specific distresses, as well as drainage, lighting, security, etc. all of this information is able to come together. So again, our ability to deliver in a simple format that can be merged into whatever's needed allowed for a full GIS deliverable based on both the in-field inspections along with the AI-based use that was done, full ratings for the client to use, and then they're actually able to take and start doing that in prioritizing where they're going to put some investments in these assets that have kind of been a little bit forgotten or just not prioritized over the years. Successful enough that we've had another asset come on board that they want to have the same program done, which was done a little bit earlier this year as well. So I think a really great way. So those polygon type assets, things like that, is a super approach to being able to bring that information together, get the spatial, get the digitization of it, and a really nice visualization that you can use to help understand that decision-making process. To summarize the discussion today, artificial intelligence, machine learning, computer vision, these are all here and they are ready for use in transportation asset management. There are benefits and trade-offs involved. It is not perfect, but it is very good. One of the key elements is that it is able to give you repeatable results within a well-defined work program, and it is very efficient in being able to get it done. Do not attempt this without a human in the loop. The idea that you just set it and forget it with AI is not something that we would support. There are needs to look at normal things that can happen with any data collection project, like a wonky GPS signal. And then there's the things to trade out the edge cases within a model you've developed that was not considered in the planning phase. And you see that. So you have that opportunity through the quality control process to enhance and retrain that model and make it better in the long term. And again, that you want to make sure the client gets the best data set possible. So you need to have a human in the loop quality control process when using AI. And we think that implementing this technology will allow you to start collecting data you couldn't collect previously or increase the frequency of data collection. Either or gives you an opportunity to bring a rich data set, spatial data set that can be used within your existing programs or visualized very well and grab information that may not have been part of what you're able to do previously. With that, I'm happy to answer any questions that may come up. And Steve, back to you.
Well, it's been a quiet group. We haven't had any questions, so maybe you're covering everything that why they attended today. One of the things, Jason, that I really appreciate was so you mentioned standards and collecting data to those standards and Pazer method of collecting data for pavement. And you told me, you said we're not quite there with doing it with other rating methodologies, and that was the one thing when you and I talked is what I appreciate, that you're not saying A, that the AI covers everything, and then B, there's some things that you're just at this point not collecting as accurate as that you would like it to be, and so I certainly appreciate that, because not all the AI companies are purporting that. So it looks like we got a question here. Does your AI software report confidence level along with interpretation?
Not in a way that I think we publish necessarily to someone. Obviously, we provide the data sets to any customers we're working with. They have an opportunity to go in and look at all the information and validate it themselves. Typically, we're not using models unless we are confident in the outputs that are there, and we have a series of scripts and checks that we run to look at it. So within our control process, stratified quality control, there's basically an element that starts depending on what type of asset it is that goes through and does a statistical check of things. It looks for particular challenges, and if it meets those, then great, we're happy and we move that data set forward. If not, there's an increase to the number of checks that are done in there. So there's a process that our team has developed and runs through, but before we pass over to the client, we're through all of that.
All right, we got another question. How much of your attribution in GIS is populated through the software versus human entered?
So the predominant elements are, so inventory is absolutely 100% AI based. That's really the means we're looking at doing here. There are some unique elements sometimes on the condition assessments that will require some human intervention with that, but the goal is to provide AI based. And as Steve mentioned, that's where we're staying back on, for example, PCI, we just haven't been able to get to a point where we feel as comfortable. So could we deliver PCI? For sure. But at that point, you're really looking at probably a 50-50 AI versus human manual programming or manual rating. So that's not where we want to head. We're working to more and more AI based as opposed to just doing things along. So I don't know an exact percentage, but I can tell you that it's 100% on the inventory, and it's the bulk of the condition rating, and those models are being refined and enhanced continuously.
Alrighty, so your attribution with RC RPC is really impressive and data rich.
Well, thank you for that. Yeah, it was a very good project, a great customer to work with. And I think what we've been really happy with is there's been really minor feedback on any data concerns at all. And they did some unique things. So we pulled out things like transit routes because they wanted to actually confirm some of their bus shelters, or bus signage. Like, I think we have some bus signs that probably shouldn't be there anymore based on route updates. So, load a shapefile and populate against it in terms of where data attribution is, and they're able to fine tune some of what they're doing. So they've been a great customer to work with, and I think we've learned a lot about just how they're using that data for to benefit their program and their organization.
What I'm really excited about is, having provided proposals for sign surveys, where you're actually physically going out and locating the signposts, and you're using the retro reflectometer, that's an expensive process. And so do you need that level of information at a network level? And I would say that you don't. And so for having this level of information, like good, fair, poor, the location, the type of sign, it can, that this is exactly what you need. Knowing the number of signs, and getting on that cycle of replacing signs, and it's really awesome. One of the things that I found really helpful is the curb and gutter, which curb and gutter has a useful life just like everything else. And you'd say, okay, well, is it going to last 70 years? Is it 80 years? But at some point, you're going to have to replace curb and gutter. So if we use the town of Cary as an example, they have $315 million in curb and gutter. And so as we do our projects, we got to make sure that we're replacing that curb and gutter, and knowing the condition, the good, fair, poor, where you have it. It's really important. And, and Jason, I don't know if you're prepared to talk to dollars per lane mile, but it's certainly a lot cheaper to collect it this way than other means.
Yeah, I mean, I think there's a couple elements. So sometimes with conventional, the prescriptive van surveys, which do a wonderful job, I absolutely agree with that. But can you get everything together at the time? And obviously, there's an economy of scale with that. So we're seeing smaller agencies who maybe wouldn't have embraced some of the digital technologies, or wouldn't maybe have been as accessible to them. This gives it away. You're not having to provide specific hardware. You can use very off-the-shelf tools, and as I said, in many cases, tools that people are already using, action cameras or smartphones, are very simple tools to bring that information forward. On a cost basis, just rough numbers, you're looking at anywhere from say $10 to $30 a mile for an asset. So on a per asset basis, and there's two components to that. There's the inventory component, and then there's the condition assessment component. So you can look for just inventory, or you can look for inventory condition, or you can mix and match based on whatever asset you're looking at. Another element with this is just because it is easy to grab the information. There's a lot of ways to grab the raw input, which is geocoded images. You can do both smaller and network level projects. So we like that ability to allow people to take advantage of the technologies and grab that information, or maybe they were sending someone out on foot before because it just was not big enough to arrange to do. Or if you're looking at a corridor survey for redesign and you just want to know what is in place, that if I widen this road, what do I have to do? People are looking at a lot with mobility for sure. So things like bike lanes and elements like that, where they really want to get a handle on where do we have them? What are the markings that are in place? We can be very responsive and flexible to that. And I think it provides a good data set. In my opinion, it's a tool as part of the toolkit, or, you know, a piece of the pie that people want to have a full pie for. So it doesn't necessarily replace everything that's out there. It's an opportunity to enhance or supplement or add new capabilities to what organizations have in place.
Yeah, absolutely. And you know, it's got to be at a price point where you can make good decisions from it, but you're not, you know, not spending all your money on a survey, right?
Correct.
So there's that.
Yeah, it's got to be. You got to have money left to do something with the information you gathered. Otherwise, what's the point?
Right. And you know, don't collect data that you're not going to use, right? Everybody
100%.
wants, sometimes they'll say, "Oh, we want this, we want this, we want this." And it's like, are you going to maintain it? Are you, you know, what do you need it for? Those are all things that need to be considered whenever you're collecting data. It's like data collection 101.
Yeah.
Jason, maybe at this point, maybe if you could pull up a dashboard and just kind of dive in and just. Oh, we got a question here in VDOT slide. What are the big numbers on aerial view shaded areas 2, 6, and 8?
To that. Without knowing for sure, my guess is they rated it in three different ways. They probably rated the periphery and then these two areas. And my guess is that would be summarized as a 2, a 6, and an 8 for the Pazer value. So,
Yep, they just broke it out into separate areas and gave them different
yeah.
ratings because they're probably pretty drastically different. Yeah.
Yep. So, yeah, let me just
Pull up
switch
the
over to the dashboard here. It'll take me a minute to change up what I've got up. Here you go. Is that up there, Steve?
not quite. There we go. It's coming. Yep, see it.
All right. So yeah, this is just a dashboard from the RCRPC project. So you can see you've got a simple map which outlines the project limits. In this case, anything that's in sort of that purple or magenta color, those are state roads or roads that were not part of the actual survey in this case, but are within the boundaries of it. Just summary statistics here on all sorts of, how many different things did we collect or look at any particular area at this high level. And then down at the bottom, you can move across, from an overview to dive into a particular aspect. So you've got, anything that you want to do from that point of view. If you want to take a look at your traffic signs and, I only want to see my traffic signs that are in poor condition, you're able to hit on that and it's going to pull information out for you. So this is always dangerous if I click on something right where I am. Let's see what we got. So you can see that they will pull where that asset is and which particular one. So you've got the actual perspective, and then the box would be around the asset that is in play on this particular one. And then this information is obviously tied to every asset. So we've got, again, the asset ID, all of that sort of information that comes on through. And within that, we can apply information based on, in this case, we're looking at various counties. We could break information down on that. If you're working in a municipality, you have some work districts or work zones or electoral districts that you like to track things within, everything can be reported from that point of view. So you can just add assets back in. You can work in here. You can select anywhere you want to go based on either a municipality within or a township within. You can filter it out by functional class. You could look up a specific street if you remember all of that. And then over here, we've got some how did we rate things? We provide access to the guides, or what were the rules that were put in place for the various assessments that were done on there. So people find that a really nice way to be able to go and deal with any sorts of information you're looking at. Again, for them, they wanted, as part of looking at drainage systems and that, they wanted to get an inventory of their manholes. So we're able to pull that up in here. So again, it'll pull up of it. You can see there's actually 2 there if we went on each one. Oh, hey, piece of information there. That reformatory in the background was actually used in the Shawshank Redemption. I remember someone telling me that was what it was famous for. So who knew? I didn't even know I was going there.
How about that?
And then we also provide, so the dashboard is really a great area when you're getting into really detailed assessment, looking at things. So, lane markings again, what are the types, what are the colors, all that information. And then we also have a nice lightweight viewer. This is pulled up based on the signs within an area. So you can filter through to any of the assets. So the asset types, and then you can filter that. In this case, I'll just stay on the signs. You'll see that signs is got single points like this, and then we've got some here that have a plus sign. So what that means is there's obviously more than one on a particular asset or a particular post. So again, we pull up and identify which one we're at, and then typically we'll provide that perspective view like you saw in the other, where we've got, okay, this is the overall asset area, and then that smaller box is the actual asset we're looking at. So there's a couple of different ways that information can be looked at. And of course, we support putting it into any sort of a decision-making system you have in place. People are using Power BI, people are using our dashboards, people have, different management systems already in place, and we 100% want them to take advantage of that information when they can. One thing I like with this particular project is when they decided they were grabbing information, they wanted a lot. It'll take a minute to pull up. If you bear with me for a sec. But if we look at all of the different types of point assets, we get ADA ramps, changeable message signs, culverts, delineators, fire hydrants, the end treatments on guardrails, light posts, manholes, other pavement drainage, pedestrian control, way stations, who knew? Rumble strips, traffic control devices, utilities, utility pole mounted lighting. So just a heck of a lot of information that can be extracted for someone to use as needed. So we really like that flexibility of what is it you're looking for. Training the model up, especially for inventory, can be done fairly quickly. It does take a lot, obviously, discussing that number of annotations and images, that clean data set that needs to be done, but it can be done reasonably quickly with the resources. And then condition ratings can be applied fairly quickly as well. Although that I think is a little more, that ends up getting more fine tuning as you go.
Have you collected trees before?
We have. Yeah, we've done trees and we've done tree wells. So that has been done. Give me a sec here. I'm going to see if I can just see if I can move to that.
So what I liked about the process, Jason, was that we did it both ways. We used the cell phones, a forward and a backward facing, and then we did it with GoPros. And but basically just using your app and then uploading the data to the app, and it was pretty straightforward process, and you guys processed the data.
So can you see that right now, Steve?
Yeah.
Okay, let me just see here if I can get in a little bit. And so we're looking at trees over here. So for this project, we did, oh, sorry, I'm on the tree. Hold on, I got to switch.
That in Florida?
No, California.
Uh,
So again, the viewer, you can pull up any sort of, so you want the satellite or whatever, but so go on trees. So marking tree location, and for this one, we're also doing tree wells. Did it have a tree well or not? So yeah, another asset that's coming in. So trees and tree wells are definitely things that we're seeing more of. Sometimes it's actually if there's sort of green space in an area. So what sort of area of green space are people looking at again when we're looking at things like rehabilitation, road widening, what's happening to things overall? So knowing what's in place, what may be impacted. It's been something we've seen people start to look at.
Another question here before we wrap up. Can you confirm, but I believe you mentioned previously that you were able to limit the view of the sign detection, meaning you can limit the view to 20 feet on both sides instead of viewing out into infinity?
Correct. So where we look at to try and bring things in, we're just not going to get accurate results. So we basically geofence the area that you're looking at. So if I go to the, let me just go to this one in the overview. So within here, we get, these are the areas that we're actually looking to import data from. So if images are from outside of that, it's not going to be done. If it's roads that are not part of it, they're not going to be looked at. And then within the roads themselves, there's going to be a bounding box that sort of says, here's 20 feet either way, and anything that's within that will be looked at. And again, based on the models that are there. So that's where, for example, we'll run into, signs is a good one. We have a very good sign model, but we get some of these signs that are right on the cusp of the right of way and private property, and they will typically, so our quality control on signs is typically removing some that are right on that edge, and we're continuing to try and refine it, but you don't want to refine it so much you're not getting what you need to get. But sometimes we end up picking stuff in. But yes, we do do the major project area, and then within the actual zones or collection corridors that are within it, we also bound that to try and ensure the right data is collected. If someone pulls in and, for example, grabs a coffee and comes back onto the road, that little drive around the drive-through is not something going to be processed, and you're looking at, why do I have a speaker in my data, as an example. So.
All righty. Well, we're just out of time. Jason, I appreciate you presenting. We're getting thank yous here in the chat. For anybody that's on the call today that's not on our email list, you can email me and I'll get you on the list so you get those. We do 2 a month prior to. And next month, August, which is really hard to believe that we're this far into the year, the topic is work zone traffic control innovations. So, by the way, Jason, yours was the 39th lunch and learn that we've given since January of 2021. And the work zone traffic control innovations, it was one we were trying to do and it flopped. So we're hoping, fingers crossed, that we're going to get to hear something about traffic control. Most of the traffic control guys are so busy they don't have time for it. So we're looking forward to Mark Blanton with JMT Teague Engineering to speak. And that will be on Wednesday, August 28th at 11:30 a.m. And you'll see an email or 2 from us. So everybody, thanks for attending and have a great afternoon.
Thank you, everybody, for your time. Appreciate it. Steve, thank you very much. We'll
Thanks,
talk to you
Jason.
pretty soon. Enjoy your day.